Hello, hi. This is PVV Satyanarayana, Physics faculty. Today we are going to discuss a refractive index of glass slab using traveling microscope. This is experiment in the 11th, 12th board examinations. It is also important. So the same concept is there in your 12th physics in the ray optics chapter in the form of refractive index is equal to real depth by apparent depth. First, let me explain the concept there and how we are going to use that concept in this experiment also. Let me explain. So we are going to find refractive index of a plain glass slab. This is what actually important, right? So here, as per our lab measurements, the thickness of the glass slab we are giving 1 centimeter. And again, the glass slab what I am taking the material, it is a ground glass. Okay, so how to do this? First, let me explain the theory part. Right? See here, refractive index. It is represented by letter mu. Mu is equal to real depth by apparent depth. So this is what actually refractive index we used to call real depth divided by apparent depth. Understood? So how we are going to find this refractive index material? So experiment to begin. Actually, we need to take a cross mark in the white paper. So I'm taking a cross mark on the white paper like this. This is placed here exactly, this in this place, just underneath of this traveling microscope. In this is a traveling microscope where this is a microscope, right? So by means of this arrangement, it will travel vertically as well as horizontally also. So in this experiment, we are using the vertical scale. This scale actually is seen here. This is the scale. In this scale, there is a vernier scale of reading 0, 1, 2, 3, 4, 5. That means 50 readings on the vernier scale. It's not actually 50, it is 0 and 0 0.1, 0 0.2. Actually, how it was, it is 50, right? It is 0. See, let me see. 2, 2.1, 2.2, 2.3, 2.4, 2.5. You need to observe here every 1 centimeter is divided into two parts. That means 2, the small line, 2.05, 2.1, 2.15, 2.2, 2.25, 2.3, 2.35, 2.4, 2.45, 2.5, like that. This is what distribution of the main scale. This is the main scale. You do remember, this is the main scale and this is called vernier scale. What is actually vernier scale? Every one division in the main scale. Every one division in main scale is divided into 50 parts. That means 2, it is 0.5, 1, 1.52, like that. So it is now just above the line. 2 key or just above the line is 2.05. 2 just below line of 2 is 1.95, after that 2.05. So what is this reading now? It is 2.50. What is this reading now? It is 2.90, 2.95, 3.00. Like that we need to understand. I hope you understand this scale arrangement. So when you move this microscope alone, there is no change in the scale. See, I am moving the microscope up and down by using this screw. So when you look at the traveling microscope, you can see this is one screw and this is another screw. This, by using this screw up and down, this actually in this arrangement, this screw, You can either move this vertical scale up and down. So when you are rotating this screw, right? When you are rotating this screw, let me see. When you are rotating this screw, right? You can move the traveling microscope up and down. Okay, so up and down we can move the traveling microscope, right? And while rotating this screw, you can evening you only the microscope only up and down it will move. See, it is moving up and down. There is no change in the scale. If I am moving this, scale also moving. See, scale is moving. Are you able to see this? Yes or no? So I hope you understand. So now I'm starting the practical. First you need to place, as I told, you need to place the cross mark. See, cross mark is being arranged. So to focus this cross mark, first step, you need to move this screw alone. You should not touch this screw. So move the screw up and down such a way. See, I'm just moving the screw. So this is out of focus. So that I'm moving this out of focus. Whenever this traveling microscope is out of focus, then only we need to touch this, right? So you need to arrange it by moving this screw. You need to arrange the image of the cross mark accurate, very sharp image. Here I'm showing here macroscopically. Right now it is clearly focused. If you look at from this microscope, you can see this cross mark very clearly. Now take this reading. See what is actually how to take that cross mark I am taking. After that, this is the reading what I am taking is without glass slab. This is a R1. This means without glass slab. Without glass slab. After that, we need to place the glass slab. First reading I need to take. So, to take the reading, this is I told already, it is a vernier scale and this is the main scale. The zero reading in the vernier scale, where it is showing in the main scale is called main scale reading. So the zero reading where it is showing 2 just down is 1. So it will be 1.9, it is 1.8. So that it is 1.8 and it is 1.85. This is 1.90, 1.952. That means it is 1.80. Once again I am explaining 1.80, 1.85, 1.90, 1.952. That means it is 1.85. So the zero reading in the vernier scale just crossed 1.80. That means what is the main scale reading now? Main scale reading is equal to 1.80 only. So 0 which reading it is crossed below reading we need to take so that it is 1.80. So this is the main scale on the main scale 1.80. That's the main scale reading. Now after that we need to know it is already in the 11th vernier calipers type only. Vernier coincidence we need to find. To find the vernier coincidence, we need to search vernier readings. These are the vernier readings. These are the main scale readings. This is the vernier readings. So from just remove with the 0, I found the main scale reading. So that remove the 0. From 1 to 50, which reading, which line in the vernier scale coincides exactly with the main scale lines. See once this is not coincide, this is not coincide, this is not coincide like that. If you go up and up, we can find one line. See this line exactly coinciding. These are the lines which are coinciding very exactly. So that it is 20 it is 0, then 20, 30, 40, 50 as I told. 50 number of readings will be there. So now it is 20, 21, 22. 23, I am taking 24, exact finding at 23 I am taking. So 23, it is a vernier scale reading. Vernier coincidence is 23. Now we need to find the least count of the instrument. Instrument. How to find the least count of the instrument here? See, least count of the instrument. See, least count formula. One main scale reading divided by number of vernier scale divisions. So what is the one main scale reading I told? 2. Next reading is 2.05. Next reading is 2.1. That means every one reading is 0.05. So one main scale reading is 0.05 centimeter. It is centimeter scale divided by number of vernier scale divisions. How many it is? 50. Look at here. 10, 20, 30, 40, 50. Understood? So it is 50. Therefore, how many? What is the least count here? See now. 5 by 5,000. It is in centimeter. That equal to 1 by 1000 centimeter. So 1 by 1000 is equal to 0.001 centimeter. So least count of the instrument is 0.001 centimeter for this instrument. Therefore, how to find, once you find the vernier coincidence, always you need to multiply with the least count. Therefore, vernier coincidence into least count is equal to 23 times of 0.001, that equal to 0.023. 0.023. Now, total reading R1 is equal to main scale reading plus vernier coincidence into LC. This is the formula. So what is the main scale reading? 1.80 plus vernier coincidence, what I got, plus into LC 0.023. That equal to 1.823. This is reading R1. Is the reading R1. Do you understood? I hope. Reading R1. Understood. Now, once you find the R1, you need to place the glass plate also. Place the glass plate. See, I'm clicking place the glass slab. I place the glass slab. As and when I place the glass slab, the mark become no blur again. Now, in this case, R2, while finding the R2. So now see what is the situation. See, once arrow mark is there, that is R1 I took. R1 is without glass slab, without glass slab. Once I place the glass slab on this, on the top, automatically what I can see, I saw the glass slab, this arrow mark, little bit up because of the refraction, because of refraction. If I saw this, no, I will see this mark here. So from the top of the glass slab until the bottom, this is called real depth. From the top of the glass slab here, this is apparent depth. So we need to find this reading also while looking from the microscope. R2 we need to find. For that, see, I am now, it is become blurred. Once the glass slab is placed, it become blurred. That means I need to focus it, take the reading. So here the scale should move. For that, I am using this screw to move. So that, and see, I am up. Just we need to move up only. So just while moving up till it comes very clear image. The first image what we saw, the same image I saw now. Now what is the reading? So while taking the reading, I told already, the vernier scale, zeroth line, where it is showing on the main scale. So already you know that this is 2, I'm saying, this is 2.5, come down, 2.4, 2.3, 2.2, this is 2.1. 2.1. Understood? So it is 2.1, 2.15. Next reading is 2.15. This 0 is between 2.1, 2.15. So that my main scale reading is just it is not crossed this 2.15, so that I need to take down line. So 2.10 is the main scale. Right now, R2 to find R2, main scale reading. Main scale reading is equal to how much we already see 2.10. 2.10. Now, what is the vernier coincidence? See, after this, leave this 0 and just go up to this. I find 30, 31, 32, 30, 34 exactly I am seeing. See, 30, right? 34 it is. 34 exactly 30, 31, 32, 33, 34. It makes a straight line with the vernier reading and main scale reading coincide. That is called vernier coincidence. So vernier coincidence we see in this case is equal to 34. Already least count, vernier coincidence into least count is equal to 34 into 0.001. That equal to 0.034. Then main scale reading plus vernier coincidence plus LC, that is R2. R2 equal to 2.134. 2.134. Once R2 also over. R2 also over. Now you just pour something like a podium powder. It is not available in our lab. Means chalk piece powder also very lightly we need to pour. We should not pour thick layer. Light chalk piece powder. 4 or 5 particles of the chalk piece powder is enough. And focus the powder itself. Don't focus the arrow mark and focus this is a cross mark. You need to focus the powder. How? See, I am showing here. Now, glass slab over, I am pouring the powder. See, I pour the powder. Again, it become blur. Now, we need to move up till powder is seen very properly. See, I am able to see the powder very properly. Now again find the reading. You know already how to find the reading. Vernier scale 0. Where it is crossing, it is 3, 2.8, 2.9 and 2.8. It is 2.8 actually. So 2.8, 2.85 middle the 0 is there. So main scale reading for R3. Main scale reading is equal to how much it is? 2. Main scale reading is equal to 2.80, 2.85, 2.90, 2.953. So it is 2.80, 2.80. Once, and I hope everyone understood it seems. Okay. Next, vernier coincidence, leave this 0, go up like this. Exactly, I can see 20, no, 21, no, 22, no, 23 also, no, 24, okay, 25 I will take up exactly, straight line. So vernier coincidence, I take 25. And VC into LC, 25 into what is LC? 0.001, 0.025. Now add both, you will get 2.825. This is R3. Now as I told, the reading mu is equal to formula real depth by apparent depth. What is the real depth actually? Real depth, this reading we have seen R3. So real depth is R3 minus top, glass slab top minus glass slab bottom, R3 minus R1. I hope you understood, right? R3 minus R1 divided by, similarly, apparent depth, top of the glass slab minus image formed by the glass slab. So R3 minus R2, R3 minus R2. So that you know already values 2.825 R3 minus R1. R1 equal to how much? R1, just find where is R1? 1.823. 1.823 divided by 2.825 minus R2. Where is R2 actually? R2, 2.134. 2.134. That equal to 2.825 minus 1.823. It is 1.002 divided by 2.825 minus 2.134, that equals 0.691. So that this value 1.002 divided by 0.691, it is approximately 1.45. It came 1.45 approximately. We need to get a mu value. Mu value is 1.5. So just to round it off, this value also approximately 1.5. Understood or not? So experiment should be done like this. Is that clear, all of you? So this is the way you need to do the experiment of this. So let me show the result. See, this 1.5. We got 1.45. So these decimals, 1.5 up to this, it is agreeable. So 1.45 to 1.5, every value is agreed. Is that clear? I hope everyone understand. I made you understood easily of this experiment. Just go to the lab and practice it. You came to understand this reality. Okay. Thank you very much.